Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue our subtopic under chapter number 2, which is interval estimation for the ratio of variance. Right. So the objective is when we want to compare the variance of two normally distributed population, right? Then we will use a ratio variance ratio, which is population variance number 1 sigma 1 squared, and then divide by sigma 2 squared. Right, the variance ratio is used among other things as the test statistic for analysis of variance. So the objective of testing a ratio of two variance is because we want to know whether the two population have equal variance or not equal variance, right? If the two variance are equal, right, then the variance ratio should be equal to 1. So this is the one of the objective lah. Right, a point estimate of the ratio of two variance is for sigma 1 squared divided by sigma 2 squared is s1 squared divided by s2 squared, which is equal to the ratio of sample variance lah. And hence, statistics of ratio of sample variance is also called an estimator of sigma 1 squared divided by sigma 2 squared, the ratio of population variance. Right. So now, let's recall some theorem, right, in chapter number theorem in chapter number 1, which is theorem number 6, right? If sample variance and sample variance number 2 independent sample of size n1 and n2 from a normal population, right? So F distribution is the ratio of sample variance number 1 and population variance number 1 divide by sample variance number 2 divide by sample variance number population variance number 2, which is also equal to the F distribution with n1 minus 1 degree of freedom and n2 minus 1 degree of freedom. So this is the F distribution with 2 degree of freedom. They have 2 degree of freedom, means n1 minus 1 and 2 minus 1. This one also we can call as a v1 and v2, right? So we can write the interval estimation for the ratio of two variance as probability of f1 minus alpha divided by 2 n1 minus 1 n2 minus 1, and this one f alpha divided by 2 n1 minus 1 n2 minus 1. So the F distribution are also same as the shape of the distribution same as chi-square distribution. It has a skew to the right distribution, right? So if you want to find this is 1 minus alpha, and this is alpha divided by 2, and this is also alpha divided by 2, right? So we're going to divide alpha divided by 2 equally lah. So this one should be f alpha divided by 2 n1 minus 1 n2 minus 1, and this is going to be f1 minus alpha divided by 2 and 1 minus 1 and 2 minus 1, because 1 minus alpha, because our statistical table give a reading on the right hand side kan. So they give alpha on the right hand side, they give bacaan kepada ke kanan. So that's why if you want to find this value, you need to minus by 1, because the summation of probability is equal to 1, right? So now look at when f1 minus alpha divided by 2 v1 and v2, and f alpha divided by 2 v1 and v2 are the value of F distribution with v1 and v2 degree of freedom, where v1 is n1 minus 1 and v2 is n2 minus 1. So the the interval estimation also can be write as this one, right? And so benda yang sama lah dengan the first previous previous slide, right? So now look at theorem number 1. So theorem number 1 says that when you have f alpha alpha v1 and v2, 2 degree of freedom, and for f alpha with v1 and v2 degree of freedom, so if f1 minus alpha v1 and v2, we can also get the value by dividing 1 over f alpha v2 and v1. So this is a theorem in F distribution, chapter number. This is under F distribution lah. Basically, you already learned this in QMT 211, right? So now, from previous, from this equation, right, or this equation, we can take either one, right? Let me derive the mathematical equation, right? So let's say we have P f1 minus alpha divided by 2. This is v1, v2, and then this is a sigma 2 squared. This is actually f, right? And this is 1 squared, s2 squared, right? This is f alpha divided by 2 v1 v2 equal to 1 minus alpha, right? So if you take sample variance to the both sides, so it became s1 squared over this is going to be s2 squared, so because s2 first and s1 later, so this is s2 divided by s1 squared f1 minus alpha divided by 2 v1 v2, and this is going to be sigma 2 squared over sigma 1 squared. Same over the right hand side, f alpha divided by 2 v1 v2 equal to 1 minus alpha. So if we want to estimate, so basically what we want to do is we want to estimate for sigma 1 squared over sigma 2 squared. So this is what we want to estimate lah. If you want to estimate the either way, which is sigma 2 squared divided by sigma 1 squared, so this is the equation. So if you want to estimate sigma 1 squared divided by sigma 2 squared, so the equation will be kita akan terbalikkan dia lah. So this one should be s1 squared over s2 squared. This is going to be 1 over f alpha divided by 2 v1 v2, right? This is kita terbalikkan semua, right? So this is s1 squared, s2 squared. This is 1 over f1 minus alpha divided by 2 v1 v2. So this is 1 minus alpha, right? So based on the theorem, right, based on this theorem, we know that when we have f1 minus alpha v1 and v2 is also equal to 1 divided by f alpha v2 and v1. So this one, kalau kita terbalikkan this one, they apply that theorem to this side, because this side have f1 minus alpha divided by 2, so this one should be equal to s1 squared over s2 squared. This is 1 over f alpha divided by 2 v1 v2. This is sigma 1 squared over sigma 2 squared. and this is S1 squared divided by S2 squared, and this is 1 over F1 minus alpha V2 V1. It become 1 F alpha divided by 2 V2 V1, 1 minus alpha, right? So this is the last equation, right? So from interval estimation of the F distribution, so we will get this equation, right? So this equation will lead us to theorem number 2. So theorem number 2 says that if S1 squared and S2 squared are the variance of independent sample of size N1 and N2 from a normal population, so then if you want to estimate, this one should be sigma 1 squared over sigma 2 squared. So I need to make a correction for this, right? So this one should be same as our derived equation. So if we want to find the confidence limit for the sample, for the ratio of the standard deviation, so we just need to take a square root of the limit, confidence limit, right? So this is very simple. So now let's look at the example, right? So but before we go there, do you understand the concept of F distribution, right? First, F distribution is just look like chi-square distribution. So when we want to find the area on the left hand side, we just need to 1 minus alpha divided by 2, right? And then the second thing that you need to understand is how to derive from this equation, from the basic equation to theorem number 2, right, which is this equation, right? So now let's look at example number 1. So far, do you have any question? Can you please put something at the chat room? Any questions so far? Question? Yes. All right. Okay. Good. So we move to the next example. This example is actually we already look at this example in previous chapter, right? We just revisit this chapter, this example. So a study has been made to compare the nicotine content of 2 brands of cigarette. 10 cigarette of brand A has an average nicotine of 3.1 milligram with a standard deviation of 0.5 milligram, while 8 cigarette of brand B has an average of 2.7 milligram with the standard deviation 0.7 milligram. So assuming that the two set of data are independent from a random sample, from normal population, so we need to find 98% confidence interval for the ratio of this is also different, sigma 1 squared over sigma 2 squared, right? So so you need, this one is sigma 1 squared over sigma 2 squared, right? So first we need to jot down the information. N1 is equal to this is brand A and this is brand B, right? Sigma 1 is equal to N1 is equal to 10, N2 is equal to 8, and then we have X bar 1 is equal to 3.1, X bar 2 is equal to 2.7, and we have the standard deviation for brand A is equal to 0.5, standard deviation for brand B is equal to 0.7, right? And then we want to find the confidence interval, 98% confidence interval. So 98%, so we draw a shape of F distribution. So we want to find 98%. So 98%, this is your 1 minus alpha. So this is alpha divided by 2, alpha divided by 2. So alpha divided by 2, which is 0.02 divided by 2, should be 0.01. This is also 0.01. So this is the rejection area, right? So we want to find this area. So this is going to be F1 minus alpha divided by 2, and this is V1, V2, F alpha divided by 2, V1, V2, right? But according to the formula, P, probability of S1 squared divided by S2 squared, 1 divided by F alpha divided by 2, V1, V2, right? And this is going to be sigma 1 squared over sigma 2 squared. This is S1 squared over S2 squared multiply with F alpha divided by 2, V2 and V1. So equal to 1 minus alpha. This is the formula. So you can either use this one, right, to back to the so then you can use this one, right, or you can use alpha divided by 2, V2 and V1 degree of freedom, right? Because in statistical table we only have I don't think we have 1 minus alpha divided by 2. We should have alpha divided by 2 only, right? So that's why you need to use this table, this formula to solve our problem, right? And for alpha divided by 2, let me use another color, right? F alpha divided by 2 is 0.01, right? Let's say alpha divided by 2 V1 V2, which is also equal to F 0.01. V1 is 10 minus 1 is equal to 9, and V2 is 8 minus 1 equal to 7. So this one should be equal to 6.72 by looking at the statistical table. When alpha divided by 2, V2 V1 is equal to F 0.01, V2 is 7, V1 is 9. So this one is equal to 5.61. So this value should be from statistical table, right? So since we already know all the value, we just need to plug in the value into the formula. So this is going to be 0.25, right? Because 0.5 squared is equal to 0.25, and then divide by 0.7 squared equal to 0.49. This is 1 over F alpha divided by 2 V1 V2 6.72, right? This is sigma 1 squared over sigma 2 squared, and this is also same 25 0.49. This is 5.61. So this is 1 minus alpha. So when we solve the value inside the lower confidence limit, should be equal to 0.076, and this one should be on the right hand side should be 2.862 equal to 98%, right? So now the ratio of variance, confidence interval of ratio of variance is between 0.076 and 2.862. So if you can see in this interval, it include 1 dalam ni kan. So this is 0.076 until 2.862. So in between we have 1. So since the interval include 1, so we can conclude that the variance for both group are equal. So we can say since the interval include 1. So we can say the variance of both group are equal. Right? So far, any question? Kena pakai formula alpha divided by 2 instead of 1 minus alpha divided by 2. So, sebab in our statistical table, let me find my statistical table. In our statistical table, if you can look at your statistical table, table number, I think table number 9, we don't have the alpha more than 0.05, which is we only have alpha 0.05, 0.025, 0.01, 0.001 and 0.025 dalam statistical table. So since we don't have the value of 1 minus alpha, right? So let's say your alpha is equal to 0.01 alpha divided by 2, right? If you find 1 minus alpha divided by 2, you should get 0.99. So this alpha value is not in your statistical table. So that's why you still need to use the theorem number 6. Theorem number 2, which is alpha divided by 2 n1. So this is this is n2 minus 1 and this is n1 minus 1. So terbalik kat sini. This should be V2 and this is V1, V1 and V2. Right? Hope they answer the question. So ada lagi? Right. So no question? So we move to the next example. Next example. This is also a same example as before in the previous topic. We just revisit the example, same example, right? So now we have two stations. So we need to justify why the population variance of this station are unequal using 98% confidence interval for sigma 1 squared. This is, I think I just copy paste this one so that I make a constant mistake. So sigma 1 squared divided by sigma 2 squared, right? So first 100% 1 minus alpha is equal to 98%, right? So our alpha is 0.02, right? So F alpha divided by 2 V1 V2, which is F 0.01, V1 is 14 and V2 is 11. So this one should be equal to 4.30. F alpha divided by 2 V2 V1, this is F 0.01, 11, 14. So this one should be equal to 3.87, right? So we just need to plug in the value into the formula. So the formula is probability of S1 squared S2 squared F alpha divided by 2. So this is 1 over F alpha divided by 2 V1 and V2. This is sigma 1 squared over sigma 2 squared. And this is same as 2 F alpha divided by 2 V2 V1, 98%. Right. So this one, plug in the value. So S S1 is 3.07, and then you need to square this one, and then this is 0.80 square 1 over 4.30 sigma 1 sigma 2, and this is same 3.07 squared over 0.80 squared, and this is 3.87, right? So when you solve the equation, you should get 3.425 for the lower confidence limit, and this is 1 over, and this is 56.991 equal to 98%. So the question asks us, justify why the population variance of this station are unequal. So the population variance for this station, both group, station 1 and station 2, are not equal because the confidence interval does not include 1, right? Since this does not include 1, so the population variance are not equal, right? Okay, 14 or 15 mana? 14 lah, because the V1 is N1 minus 1 and V2 is N2 minus 1, right? So you need to minus 1 for each degree of freedom, right? Okay, so let's look at the last example for this topic, right? Last example for this topic, which is example number 3, right? So this is actually the past year question. Like x1, x2 until xn, and y1 and y2 until yn be distributed as normal distribution, which mean equal to mu x and variance equal to sigma x. And for y is mean equal to mu y and sigma squared equal to sigma is equal to, sorry, variance equal to sigma 2 sigma y. So basically this is a sigma, right? Sigma 2 squared, right? It should be variance. So assume that both population mean and variance are unknown. Both population variance and mean are unknown. So given that x bar is equal to summation of x divided by n, and y bar is equal to summation of y divided by m, and then we have S sample variance equal to summation of xi minus x bar square divided by n minus 1, and sample variance yi minus y bar square divided by m minus 1. So the first question is derive a 1 minus alpha 100% confidence interval for the ratio of two population variance, where x square n minus 1 is this is a chi-square distribution, right? Chi-square distribution with xi minus x bar squared divided by sigma squared. So this is also equal to n minus 1 s squared divided by sigma squared. So this is based on theorem number 3 in chapter number 1, right? So since you only focus on one, right? So let's look at this one. So first we have sx square equal to summation of xi minus x bar squared over n minus 1, right? So this is also, if you take n minus 1 to the left hand side, so it become n minus 1 s square sx square is equal to summation of xi minus x bar squared, right? So when we divide these two equation this equation with population variance, right? Let's say let divide this equation with population variance. So we will get n minus 1 sx square divided by sigma square is equal to summation of xi minus x bar squared divided by sigma squared, which is also equal to the chi squared with n minus 1 degree of freedom, right? Same goes to the y, right? Let's say y, kita letak another color. So let's say number 2 sy x xy square summation of yi minus y bar squared divided by m minus 1. So this one same step as previously, m minus 1, kita bawa m minus 1 to the left, and then this is going to be sy squared summation of yi minus y bar squared. So we divide by sigma, we will get m minus 1 s squared divided by sy squared sigma squared. So this is summation of yi minus y bar squared divided by sigma squared. So this is also n chi squared with m minus 1 degree of freedom. So from the definition of F distribution, so F distribution, if you still remember in chapter number 1, when we divide 2 chi squared, right, we will get F distribution, right? Let's say chi squared with n minus 1 divided by its degree of freedom divided by chi squared m minus 1 divided by with degree of freedom, we will get f n minus 1 m minus 1. So this is also equal to, let's say, let's put this equation together. So we have sx square n minus 1 sigma x square is 1 divided by its degree of freedom sy squared m minus 1 sigma y squared divided by its degree of freedom. So kita akan dapat benda yang sama, and then this is also equal to F distribution with n minus 1 m minus 1. So dia lebih kurang dekat s square sigma y squared, and the formula for the denominator is sy squared sigma x square, right? Benda yang sama, right? So this is the equation. So now we just want to derive the confidence interval, right? So let v1 equal to n minus 1, v2 equal to m minus 1. From the raw equation, f1 minus alpha divided by 2, v1, v2, right? This is f. F is also equal to s. This is sx square sigma y squared divided by sy squared sigma y sigma x square, right? And then this is f alpha divided by 2 v1 v2, right? This is very simple. We already derived it before, so we just plug in the derivation in this example. So this one should be 1 over f alpha divided by 2 v1 v2, and then this is sy squared sigma x square. Sebab what happened here is I terbalikkan this one. So I nak this one dekat atas and this one letak dekat bawah. So everything terbalik. Right? So this is sx sigma y squared. This is 1 over f 1 minus alpha divided by 2 v1 v2. 1 minus alpha. So we take as sample standard deviation, sample variance to the both side. So become sx square sy squared. This is 1 over f alpha divided by 2 v1 v2. Right? This is tinggal sigma 1 squared over sigma 2 squared. This is by looking at theorem number 1, this topic. So it became s x squared divided by sy squared f alpha divided by 2 v2 v1. So equal to 1 minus alpha. So we already derived the equation. So the estimator, so this is the estimator lah. Right, you just copy this one. Let's say I copy this one. Right, so it became, this is the estimator lah. Right. Okay, that one is for question A. Right, we just derive the equation of confidence interval for ratio of two population variance. Right. Now look at B. For B, given that n equal to 13, m equal to 12, sx equal to 0.6, sy is 0.86. So we need to calculate 95% confidence interval for the ratio of two population variance. So it's just very simple. We just need to plug in the value. Right. So let's use another color. This is B. So we know that n equal to 13, m equal to 12, sx equal to 0.6, sy equal to 0.86. We want to find 95% confidence interval for the ratio of two population variance. So we just need to plug in the value into the formula. So P sx 0.6 square 0.86 square. This is 1 over f alpha divided by 2. So our alpha here is 1 minus alpha is 95%, right? This is 95%. This is going to be 0.025 and this is also 0.025. So f alpha divided by 2 v1 and v2, this is f 0.025, v1 is equal to 12 and v2 is equal to 11, right? So this one should be 3.43, right? By looking at the statistical table. Another one is alpha divided by 2 v2 v1, which is also equal to f 0.025, 11 and 12. So this is going to be 3.325. So now I just need to plug in the value into the equation je lah. Right. So probability of 0.60 squared divided by 0.86 square. This is 1 over 3.43. This is sigma 1 squared over sigma 2 squared. And this is 0.6 squared over 0.86 squared. Multiply with 3.2325. equal to 98%. So the value of lower confidence limit should be 0.1419. This is P. This is going to be 1.6183. So by looking at this formula, this value, this interval include 1 in the equation, right? So when we include 1 in the interval, so we can say that it have equal variance. For C, based on answer B, should the equal variance assumption be used? Justify your answer. So C, we can say that since so let me use another color. Okay, the variance are equal because the value 1 is included in the interval. Right. So that's all. Right. So far, do you have any question? You can write it into chat room. Any questions so far? Hello, any question? Ada soalan tak? If you don't have question, then please put something in chat room so I can know you have question or no question. So basically, you understand all my all the example yang I bagi dekat you, semua you faham kan? Right? Ada soalan tak? Betul-betul tak ada soalan, eh? Alright, good. So I have another example, right? Example number 4, 5, 6, and 7. So this example just revision, right? So you want to continue or you want to end here? We continue next week. So I think for example number 4, 5, and 6, 4, 5, 6, 7, we continue next week lah. Right, I will save it for next week. So next week we will do some revision on Monday, and for Tuesday we will start a new topic, chapter number 3, sorry, which is hypothesis testing. Right, so I guess that's it. Thank you very much. Assalamualaikum.